on number 6, it says solve the definite integral. And we have 4 plus 3x dx. And you'll see that we have actually numbers on the integral symbol here. So these are called limits of integration. And they're really telling us where we're taking the integral of, or where we're finding the area from. So the -1 here is like our A, and our 3 is like our B. So we're trying to find the area from -1 to 3. And they are specific about wanting us to use the definition of the definite integral, meaning we have to do it the long way. This is kind of like the derivative chapter where we had to do derivatives the long way, and then we were able to finally use the rules. And even though we've already used the rules for the integral, we still need to use the definition of the definite integral, so all of the series notation on this one. So the delta x is going to be 3 minus a minus 1 over n, so that's going to be 4 over n. I'm going to circle that because I want to refer to it. My xk is going to be -1 plus 4 over n k, and I'm also going to refer to that. So I want to take the limit as n goes to infinity, and again I'm plugging in to my original function this x of k value. And again, what the definition of the definite integral does is it's taking, this is representing the height, this is representing the width of the rectangles, and this is summing up an infinite amount of them. So this will give you an exact area, not an approximation. So then let's do a lot of simplifying. And if you want to show more or less steps, that's okay, as long as you're doing it this way. Then I want to distribute the 4 over n. Okay, so then I want to split up the summation. So I'm going to put the sigma notation with the 4 over n, as well as with the 48k over n squared. And we put kind of a boundary here because it's running into that. Okay. So now I want to pull out all the non-k values. So anything that's not a k, I want to take it out of the series. Okay, so that I want to use the sigma formulas. And again, I'm going to use those sigma formulas on this one and this one. The 4 over n and 48 over n squared, those are just going to stay as they are. But the sigma formulas I want to use on these two. So let me go to the next slide and start again. So that'll be the limit as n goes to infinity, 4 over n times n plus 48 over n squared, and that sigma got replaced by n times n plus 1 over 2. So let's do some more simplifying. That's kind of the name of the game on these problems. Let's do some more simplifying and then continue to do more simplifying. So I have 24 n plus 1 over n. And then let's distribute that 24. Okay. And then I want to split up that n. And then finally, we can actually use the limit. So if you plug in infinity for n, this would be 4 plus 24 plus 24 over infinity is 0, and this will give you 28. Again, 28 is the exact area. This is not an approximation. This is the precise area. Okay, so again, a lot of work on this, lots of serious work. In the next section, section 5.3, we will discuss the fundamental theorem of calculus, which allows us to do these quicker.